Hello everyone. In today's session of CCNA series, I'll discuss queuing and scheduling. In normal working scenario, a router receives a packet and makes a forwarding decision and then sends the packet out through the outgoing interface. But during the congestion, the outgoing interface will be busy and the router will keep the outgoing messages in a queue, waiting for the outgoing interface to be available. So queuing refers to the process of managing the order in which the packets are transmitted from a network interface. It is a critical component of network traffic management. The queuing system may use a single output queue or a queuing system with multiple queues depending upon the queuing component used. You can say like it uses first in first out scheduler. So let's look at the components of queuing. So queuing components include classifier, queues, and scheduler. To use multiple queues, the queuing system needs a classifier function to choose which packets are placed into which queue. The queuing system needs a scheduler as well to decide which message to take next when the interface becomes available. And the scheduler prioritizes one queue over the other in some way, and it is referred to as prioritization. Let's look at different types of scheduling, starting with round-robin scheduling. When Cisco router uses round-robin method, it cycles through the queues uh, in order, taking turns with each queue. So in each cycle, the scheduler takes through each queue, for example, takes some messages from Q1, move on, and takes some messages from Q2, and then takes some messages from Q3, and so on, starting back at Q1. So round-robin scheduling also includes the concept of waiting, in which the scheduler prioritizes one queue over the other. Right now it is doing round robin. It will go to first, second and third and then again repeat. So router use class-based weighted fair queuing or CBWFQ, which guarantees minimum amount of bandwidth for each class. Before it was using round robin, but here it is guaranteeing some bandwidth. CBWFQ uses weighted round robin scheduling algorithm in which the admin defines the uh, weighting as percentage of link bandwidth. Here in this setup, three queues in the system have been given. First queue 50%, second is 30%, and then 20% of bandwidth each respectively. Uh, as you know, voice and video, particularly phone calls and video conferencing, need low latency, low delay, low jitter, and low loss. Okay. Unfortunately, a round robin scheduler does not provide this enough low delay, jitter, or loss. So the solution is to add the LLQ to the scheduler, which will solve the problem. This is another type of scheduler. Okay. Or you can say it is called LLQ, also known as low latency queuing. It is a queuing mechanism used in networking to prioritize delay sensitive traffic such as voice, video to reduce latency and ensure a more predictable performance for those applications. As you know, in round robin queuing system, with a when a voice packet arrives, it is forwarded through Q1, which has a 50% bandwidth assigned. But for the next voice packet to be forwarded, the scheduler uh, has to send data from other remaining queues as well. This adds delay and jitter, so which is not acceptable for voice calls. So LLQ solves this problem by telling the scheduler to treat one or more queue as special priority queue. So it offers needed low delay, jitter and low loss for that traffic in that queue. For example, the queue in which you pass the voice packet, so make it as a LLQ or low latency queuing. So every time the packet comes, it will be treated with a special it will give special attention to that queue. So that's it for this session. I hope this was informative for you. Thank you for watching. In my next session, I will discuss about shaping and policing.